Kia ora te whānau, welcome to a video 4 in our components and circuits series. Today we're going to be looking at inputs and outputs. So we've looked at outputs before. We have looked at using an LED on the breadboard as a really simple basic output. Hopefully you have done the traffic light challenge where you've used 3 LEDs, red, green and yellow, and you've been able to cycle through them. Today we're going to be looking at inputs, and what is the most basic input but a switch. So we have a switch circuit here, and you'll see the challenge up on the screen. Your challenge is to make your Pico turn on a green LED when a button is pressed. It should then turn off when they release the button, and a red light should turn on. I have a circuit down here, but you'll see that it's backwards. Maybe I didn't read the question properly. There is an extension there as well for you fast finishers to make the green light blink if they hold the button for more than 5 seconds. Ooh, that's an interesting challenge. How might you start to tackle that? Anyway, let's look at the circuit, how we have it here. We have our Pico plugged into the breadboard. We have a switch. I wish I had something a bit better to point with, but that's okay. We have our switch here. That's a really tiny little component there. We have our switch right here. We have a green LED, and we also have a red LED there. And what happens when I push the switch? Hey! The circuit changes, my output changes. So I have a really basic input, is the switch pressed, and 2 really basic outputs. One LED says, is it pressed or not? And the other one says, is it not pressed or not? Even though they're backwards, but we'll fix it up. Okay, here's what I'm going to do. I'm going to break the circuit down. I'm going to lay out the components, and we're going to build it back up together, and then we're going to code it. See you in a moment. And we're back. Okay, here's everything that you need today. You need your breadboard, you need your Pico plugged into it, and the cable, of course. You need a push switch. A little note on these push switches is that they connect up when they are broken, when they're open, not pushed. They break the circuit, so the circuit is incomplete. But then when you push the button, this from, oh, I hope it can focus, that leg to that leg there becomes connected. That leg to that leg there becomes connected. So then you can complete the circuit, and whatever it's connected to, in this case a GPIO pin on the Raspberry Pi, will be able to detect that. I have 2 LEDs, one red and one green. I have 1, 2, 3, 4, 5, 6 jumper leads, male to male, and I have 3 resistors, a 330 and another 330, so 2 330 ohm resistors, and a 10k ohm resistor. Make sure to look up the colors on those resistors to make sure you get the right ones or thereabouts. A little bit of difference is okay, but not too much, or things start to go a bit funny. Okay, first thing to do is to decide what pins are we going to use and to connect everything up. Now, you should know how to connect up LEDs by now. So let's go ahead and do that really quickly. I'm going to connect up the red LED. Just along here, I'm just going to pick any old rail on the breadboard, and I'm going to connect the long leg. You'll see one of these legs. Oh, it's not focusing. One of these legs is longer than the other. The long leg goes to the positive, short leg is negative. So I'm going to take a rail nice and close and just put it over that bridge. Another one, my green LED, short leg is going to go that way. Long leg's going to go that way. In our breadboards, we want to set it up so everything down this side is positive, and it's going to move across to negative that way. So that you don't have to do that. That's not required, but it is traditional. So we like to keep it that way so that things don't get too complicated and we don't end up tripping over ourselves. So if there's anything that's positive or negative, we're going to end up, positive is going to be traveling from here across to here. Okay? Right. I'm going to take my resistor, my 330 ohm resistor, and connect it up to pin GPIO pin 15. So pin 15 is going to control my red LED. Whoa! So that's going to go from my GPIO pin 15 into the same rail that my red LED is on. My green LED is going to be controlled from pin GPIO pin 13. So I'm going to just come back over here and I'm going to just look up this image. Whoops, let's bring that over a little bit. Here is my pin out diagram. And go away that for a second. Okay, this pin here is my red LED. I'm going to take pin 13 for my green LED. I could have taken pin 14, but I don't want my wires to touch, so I want to give them a little bit of clearance. Okay, so I'm going to take this pin, GPIO pin 13, as my green LED. All right, come back. Okay, I'm going to do this one slightly differently. The reason for that is that my resistor, all of this is bare metal. And if metal touches metal in my circuit, I have a short circuit. And things aren't going to work properly. But if I use a jumper lead, well, this jumper lead has metal here, and it's coated in plastic here. So I don't have that problem. So I'm going to use jumper leads where I can, and not use them where I don't have to. Okay, so I'm going to connect up pin 13. Oh, and let's just double check where that was. Where is that? Okay, that is GPIO pin 13. I'm coming in 1, 2, 3, 4 there. Here we go. So here we go. 1, 2, 3, 4. I want that one there, and I'm going to plug that into a rail next to, but not on my green LED. Do you see that really, really carefully? It's plugged in next to, but not on my green LED. I'm now going to take my resistor and put that across there. Why do we need that resistor? So you don't blow up the LED. We've talked about that a lot. We've already calculated the resistance that we need using Ohm's law. We're just going to pop that in now. That's a 330 ohm resistor. Make sure you get it in the right rail. I'm not at the moment. There we go. Pop and just bend that leg. Oh, it's fighting me today. Bend. Make sure it's clear of all the other components. Okay, nothing has come out. You've got to be very careful just with the breadboards and make sure everything's got a nice, strong connection. Okay, time for a switch. What we're going to do is we're going to use this GPIO all the way up here. This GPIO is GPIO, General Purpose Input Output. We have been using it so far just as an output, but we can also use it as an input. It can tell if the switch is pressed or not pressed. How? How can it do that? It can detect voltage. If the switch is closed, then the circuit has voltage, and it can detect that the voltage is high. If the switch is open, the circuit is broken, there's a gap there, no electricity flows, it detects 0 voltage. Okay, so I'm going to take my switch and I'm just going to place it nice and clear of my other components. I'm actually just going to rotate it 90 degrees to what we had before. No, I can't do that. I have to turn it this way. It won't let me do that. Okay. I'm going to place it across the gap like that. As you see, it's just placed across the gap. Now, when I press it, it's going to close a circuit from that rail back down to this rail. So it's going to be across and back down. So I need to provide high voltage here. I need to provide high voltage here. And then I need to send the output of the switch across to GPIO pin 0. Should we do it? Okay. I'm going to take high voltage. How do I take high voltage? High voltage here, you'll see this pin, pin 36, 3V3. What does that mean? 3.3 volts out. So we're going to send 3.3 volts out to the switch. I'm actually going to send it back to this positive rail down here. So I'm going to take pin 36. What is that? 1, 2, 3, 4, 5. The fifth pin down. 1, 2, 3, 4, 5. I'm going to put in that rail, and I'm going to bring it across to my high rail here. Oops, just get in there. Now, don't forget on a breadboard, that means that all of this now has 3.3 volts on it. All of this is now charged with 3.3 volts the whole way down that rail. So I'm just going to get another jumper lead, and I'm going to, I'm actually not going to use a jumper lead there. I'm going to use my 10,000 ohm resistor. We don't need that much voltage for our GPIO pin to detect it. I'm going to use my 10,000 ohm resistor, 10k ohm, and I'm just going to use that as a little jumper lead across from high. Whoops. I'm going to take that from high, and I'm going to put that to one leg, whoops, of my switch, and double checking, my head's popped out of frame, double checking that that's actually in the right place. Okay. I think we're pretty good. I've got my resistors and my LEDs. I've got my LEDs. I've got my switch here. Cool. Couple of things I don't have. My LEDs are not on a complete circuit yet, so they need to be sent to ground. I need to connect ground up to my Raspberry Pi Pico, up to the Pico, to complete the circuit. And then I need to connect this last leg of my switch to whatever GPIO I'm using as input. Cool. So I'm going to take, I'm just going to take ground. As you can see, the easiest ground for me here is pin 38. So I'm going to take pin 38, and I'm going to put it against the ground rail there. That's going to mean that all of this rail here is now on ground. That blue all the way along the bottom. All that blue along there is now connected to ground. And here we go. Connect the red LED on that rail to ground. Connect my green LED. Again, the colors of your jumper leads don't matter. Connect that LED to ground. Okay, lucky last. Is it going to reach? I don't think it's going to reach. What can I do? I can go and get a longer jumper cable. There we go. That one's a bit longer. I'm going to connect this other end of my switch. And I think we decided last time we're going to use GPO, GP pin 0. There it is. Hey, look, it's working. Why is it working? Well, it's because it's still running the previous code. And hopefully, there we go. It's working. Okay. You won't have that kind of satisfaction having it running straight away, but at least that tells us that it is wired correctly. Okay. I think we're going to do this in two parts. That is the wiring done on the breadboard. We're going to go to programming, but first, I want to talk a little bit about debugging. It's very tricky to wire this up correctly first time. And in fact, it's very easy to get it wrong. So we're going to be spending a little bit of time figuring out how we can check and how we can verify that everything we've done in here is correct. Let's go through one more time. I have a red LED. It's connected to GPIO pin 15 via a 330 ohm resistor. Double check that on your circuit. I have a green LED. It is connected to GPIO pin 13 to a 330 ohm resistor, which is then connected to the leg of the LED. The long legs are towards the positive side, short legs are towards the negative side. I have a push switch. I have my positive rail connected to this pin 36 and making this rail all positive. I then have a 10k ohm resistor which is connecting one leg of my switch, and then the other leg of that switch is connected all the way out to pin 0. I have my LEDs legs connected out to ground and ground connected back to the Raspberry Pi. Double, triple, quadruple check all of that on your circuit. And look, sometimes it can go off. I have a dry connection somewhere. Something's just popped off. You can see it's that one. So if things aren't working, double, triple check, go back through and debug your circuit to make sure it's working correctly. Okay. Next video, we will program this up to get it working correctly. Ka pai whawhatai. I will see you in the next one. Ka kite e hoa.